Okay. So we're going to run a method. The description is that we're going to run at 0.05 millimeters per minute until we reach a set value. This is as per the standard, and then the speed will increase to 0.2 millimeters per minute. This is the rate of loading the beam. Okay. So if we go to test, that's what we're doing. Next. Okay. Okay, so we're going to get a live display here on these two graphs, which will show us the output from the machine's transducers. So everyone's ready, we'll go. Stand back out of the way. Software is quite flexible. You can put different parameters in. You can set your graph up to be reading different results. You can also add or remove any results that you want. It's very, very flexible. But as I say, our applications department are in the process of creating a custom testing method that will completely suit the standard that we're working for. You have live readouts, these form here, or what they say. They're repeated on the handset there, so the operator, if he's driving it from a handset, can see what's happening. Still a little gap yet, we're not down onto the beam. Once it becomes in contact, you'll see the load value will increase quite rapidly. That graph is basically just noise, the vibration of moving. The load cell is so sensitive.
After that, your graph will also change.
Yeah.
We can still do, there is still some.
No, not touching it.
That one is opposite to yesterday we had a beam that was slightly concave.
Convex.
Yeah.
This is concave. Yeah.
But you can still just see the daylight. It affects it.
Yes, now it's
beginning to bite. Load is going up.
still is very, this is the importance of making it on a flat surface.
I'm sorry,
making of the beam in a flat surface.
Yes, I did explain this, that it's very important when you're preparing your specimens to try and find notch the flattest side for the
notch,
point and the notch on the
bottom side, which is not very
absolutely. The only one problem we have at the moment, it may happen, the power here is not perfectly stable. There is a fluctuation on the power.
Okay.
We have a device on the computer, an uninterruptible power supply, which is fine. We need a larger one for the machine, because if you get too big a fluctuation, you can lose the communication. If that happens during a test, you lose the data. So the customer is looking to get a UPS that will be suitable for this machine, which will resolve that issue. Unfortunately, it happened to us yesterday, didn't it? When we were coming to the end of the test, it lost the data. But, something that needs to be addressed. Hopefully, when the machine is located to its more permanent installation, the power situation will be a little better. It's always difficult when you're on a temporary site. say this.
More than 4. More than 4. Like just
What we need.
You know, it will reach 8 to 10. How much we were getting maximum? 10?
7, 8.
7 to 8. So LOP is 7 to 8. So 29, 30 I think. Yes, 23 already.
Yeah. I thought I heard a little click.
But have you done this test with some of the customers?
I'm sorry, am I?
Have you done this kind of specimen?
No, it's new to me. Instron, as a company, have supplied it for other customers, but
Not done this test.
for me personally, I've done 3-point pen, but with metals, not with.
Not with a computer.
Crackers it is.
This is basically a concrete with some steel fiber in it.
Yeah.
So which give a tensile strength to the concrete.
Yeah, the majority is more common for steel, and also some composite materials for ceramics and things, especially in things like in aviation industry now, with lots of composite materials. They're testing this type of testing. If you think about it, this is a composite material, so it is exactly just different type. So.
Something we have a crack and then it starts load going again because the fiber inside start working and then it goes up.
Okay.
How much deflection we going to look at? Yes.
I put 4 millimeters, which is what the standard said to end the test. But, it's adaptable. You can. So we were modifying it yesterday because all of the units were in imperial, so everything was in pounds and everything was in inches. So if I missed a few things on there, it just can be modified. But I think I've cleaned most of it up now. Remember yesterday we had inches and, and pounds.
Yeah.
And, full test is going to take approximately 20 minutes.
20 minutes.
Can I cross-check somewhere the speed of the loading in no police?
Yes, in the method it can be. At the moment, the standard says for the first 1.1 is at 0.05, and after that it goes to 0.2. But there's no reason why you couldn't have a third speed if you wanted to make the test. If you have all the data you need in the first section, you could say after a certain period we will speed the test up to.
No, that's okay. What my concern is some QA part of. So I just want to see what is the speed of
No,
loading.
you want to make sure.
What is the speed of loading now? Just to see that.
Is there any way you can
Cross check
check?
so I can see somewhere in the screen
Oh.
where it's showing, what is it?
Well, I'd have to look into that because it's set in the method, and the method, the machine is calibrated, so we know it's good. This is
No,
what you calibrate it.
just for the cross check point of view whether.
Okay. So what you're saying on the display, you'd like to see the loading rate?
Yeah, just is running on that.
Think it.
I don't know.
We can, I think, put it on the page that it will say at the moment it is loading at this rate.
Yeah.
I'm almost certain we can do that.
It's not necessary, but just I am trying to see whether.
And also in the report at the end, it will say for the first so it was at this rate, and for the second it was at this rate.
That is okay. That is standard. If you put it that parameter, but now just to verify whether it is really going that speed or somewhere.
You could select a live time display up there. You could put a time display for the time of the test, and then you could correlate between the time and the displacement, and you would know.
Yeah.
That wouldn't.
Telling you average.
Yeah. For instance, if you know it's going to be 0.2 in 1 minute, you could just say.
For 4 mm, how much time you take it?
Yeah. You're limited to 4 live displays. That was the limit. Oh, we've lost communication. This is the machine. See what happened yesterday.
Something happened with the
Unfortunately,